Scaling applications in Kubernetes often requires persistent, shared storage that multiple pods can access simultaneously. That's where ReadWriteMany volumes and Vultr File System comes into play. Hi, I am Ridul Swarup, a developer advocate here at Vultr. In this tech talk, we'll start by understanding why RWX volumes are essential for modern workloads. Then we'll explore how VFS provides a high-performance shared storage solution for Vultr Kubernetes Engine. Vultr File System is a high-performance and scalable cloud storage solution designed for seamless data sharing across multiple environments. Whether you are running virtualized machines or containerized applications, VFS ensures that your storage is both reliable and flexible. Unlike traditional block storage, VFS is optimized for distributed workloads, enabling efficient access across multiple instances. This makes it an ideal solution for applications that require persistent shared storage without complex network configurations. As your storage needs grow, VFS scales dynamically, ensuring that your applications always have the resources they need. With its high availability and performance-driven architecture, VFS is designed to support modern cloud workloads efficiently. One of the key features for Vultr File System is its support for ReadWriteMany or RWX persistent volumes. RWX allows multiple Kubernetes pods to read from and write to the same storage simultaneously. This capacity is essential for applications that require shared access to data, such as content management tools, collaborative systems, and distributed computing environments. Without RWX, teams often face limitations where each pod must have its own dedicated storage, leading to inefficiencies and data duplications. By enabling shared access, RWX simplifies architecture. It also improves data consistency and collaboration between services, making it easier to build resilient, scalable applications in Kubernetes environments. When integrated with Vultr Kubernetes Engine, Vultr File System unlocks even more potential for cloud-native applications. The biggest advantage is seamless RWX support, which ensures multiple pods can access the same data without additional configuration for workloads that rely on shared storage. Additionally, VFS scales dynamically with demand, ensuring that your applications never run out of storage resources. The ability to share seamless data across Kubernetes nodes reduces complexity, improves efficiency, and enhances overall performance. Whether you are running high availability applications, AI/ML workloads, or multi-user platforms, VFS with VKE provides a streamlined, cost-effective, and scalable solution for modern cloud architecture. Next up, we have a demonstration in which we are going to set up RWX volumes on Vultr Kubernetes Engine using Vultr File System. Now, the first step would be to deploy a Vultr instance in which we are going to configure our Vultr Kubernetes Engine cluster. The next step would be to provision a VKE cluster. On that, we will provision our RWX volume using Vultr File System. So let's go ahead and begin. Here, let's click deploy now. We have to select an instance type. For us, dedicated CPU is enough. For a region, I will select a region near me. For the plan, I will be needing 4 GB. Let's go ahead and configure the server. For operating systems, let's select the latest Ubuntu version. Let's provide a server label. We have some additional features provided by Vultr. Most of them you will see are free. These are for additional resilience to your server. Now let's go ahead and deploy the server. Meanwhile, when our server is getting created, let's go ahead and provision a Vultr Kubernetes cluster. Here, let's click on Kubernetes. Let's select add cluster. Let's provide a cluster name. Let's select enable high availability. For the node pool type, I have selected optimize cloud compute, and the plan selected already is enough for us. Let's select a location similar to our server. Now let's go ahead and deploy the cluster. We need to provide the cluster a label as well. So let's go ahead and deploy now. As you can see, our cluster is getting deployed. Once the server and the cluster both are ready, the next step would be for you to configure your server with the Kubernetes cluster. And then we'll go ahead with attaching an RWX volume using Vultr File System. Here I am logged into my server. I have already configured my Vultr Kubernetes cluster with my Vultr instance. The next step would be to create a YAML file which will define the RWX volume resource. So let's go ahead and create the resource file. Here's my resource file. So now I'm going to copy my resource file, paste it here. As you can see, my PVC is named test RWX. It has ReadWriteMany access and its storage class is Vultr VFS. So now let's save this resource file and apply this resource to provision a common storage for all our cluster nodes. Now let's apply this file. As you can see, our resource is being created. To check on the status, we will apply another command to see if our resource is bound to the cluster. As you can see, our status is bound. This is how you can provision a common storage on your Vultr Kubernetes Engine cluster using Vultr File System. Thank you all for joining today's Tech Talk. I hope this session helped you better understand how RWX volumes and the Vultr File System can enhance your Kubernetes deployments. Shared storage is critical component for scalable and efficient applications, and I am excited to see how you leverage these technologies in your own projects. Thank you again. Looking forward to see you in the next one.